Dear students, welcome to Corner classes. Today we are going to start a new chapter, vectors. These are the main topics will be covered in today's class. Before we get into our main subject of today's class, I just want to play one quick video on vector just to give you the understanding of what it means and what we are going to deal with.
Excuse me, how do I get to the museum?
Go to the end of this road. Turn right at the junction and walk for 2 blocks. You'll see a museum on the left.
Thank you.
So here what we see that this person is giving direction to a certain place, how to go and how to reach and what is the easiest way to do, and this is exactly what our GPS system does. So GPS system, as we all use Google Maps, and there we put our destination and we know what is the source, and it guides us which are the way to reach that place, what is the shortest distance, what is the shortest time, so many things that GPS does. So now what we understand from that certain things are there which goes by some direction. Till now we have dealt with lot of quantities, lot of items around us, and now we are segregating these items into 2 broad categories. One which has only magnitude and another one which has both magnitude and direction. So I would write only magnitude and another one magnitude plus direction. As we have seen in the video, the person is telling go left, go right, walk 2 blocks. So now we have seen there are certain quantities that have only magnitude, like mass, charge, energy. These quantities have only magnitude, no direction, and these are called scalars. And there are certain quantities like displacement, velocity, force, these quantities have both magnitude as well as direction, and these quantities are called vectors. So this is the main difference between scalars and vectors. Scalar goes with only magnitude and vector has both magnitude and direction. So we'll deal with vector quantities in our today's class. So vector quantities not only go by the direction but also it follows or obeys vector algebra. I'll just quickly show you the fun of vector algebra and how we deal with vector algebra, and this is the new concept of vector. This is a big topic, but in our syllabus we have certain understanding, so certain clarity. I'll give you certain clarity so that you understand how vector algebra works, unlike our normal algebra. Let's say I have 4 kg apple and I buy 3 kg apple, so total I will have 7 kg apple. Okay, now if I go say 4 meter towards east, this side is east, this is west, this is north, this is south, normal convention what we use, and I start from point A and reach point B, and from there I go to point C, and B to C, let's say 3 meter. So total how many meter do I cover, how much distance do I cover? Again same, say 7 meter. How it is coming? That 4 plus 3 meter. So total distance I am covering 7 meter. This is good. Now I tell you I go 4 meter from A to B, and then I take U-turn, I come back 3 meter after taking U-turn, and I reach a point C here. So what is the distance between A to C? So here A to C, the displacement is 4 meter towards east, and then 3 meter towards west. So total displacement is coming 4 minus 3, 1 meter, and this is the shortest distance between point A and point C. So we understand this one, and this goes hand in hand with our regular scalar quantity addition and subtraction, because it is by common sense, as it is going opposite direction, so we are doing this way. Now if I tell you, say I go 4 meter from A to B towards east, and then I go 3 meter from B to C towards north, so same sign convention we are using, then how much distance do I cover, how much is my displacement from A to C? So what is the value of A to C here? So when I give this symbol or arrow on top of any distance, then it is called as a vector or displacement. So displacement is a vector, distance is a scalar. We have all seen that, we know that. I am not spending time on it. Now here the point comes, what is my distance, or what is my shortest distance A to C, what is my displacement A to C? So we can, if this angle is 90 degree, so quickly we can use Pythagoras theorem, means we can use AC square equals to AB square plus BC square, and what we get, it is coming to, say it is 4 meter, it is 3 meter, then it is coming to 4 square plus 3 square, and what will be the value of AC? Root over 4 square plus 3 square, 25, then it is coming 5 meter. So AC distance is coming 5 meter. Now see the fun. Fun means I am adding 4 with 3 and I am getting the result 5. So till this point is okay. till this point is still okay, because we know the normal Pythagoras theorem and we apply that. Now let us make it bit more complex. Complex means let us get a different scenario here. So what is the different scenario? So A to B, and here I make an angle theta and I go to point C. So first I go from A to B, then I reach the point C from B to C. So now the question is, what will be the displacement A to C? What is the displacement A to C? So for our ease of understanding, let me use, this is A and this is B and this is C, AC equals to C. So C will be equal to vector sum of A and B, and here comes the vector algebra. This is also vector algebra, this is also vector algebra, but here all we use our common sense and we get it. But when it comes here and it makes an angle theta with another vector B, A vector and B vector making angle theta with each other, then how much will be the distance or the shortest distance, the displacement C. So this is exactly what we will learn in this particular chapter. So this part we will discuss more in detail and how we can deal with this part. So this is the question and we'll solve it, but before we solve it we need to understand few more things before we solve this one. So I'll come to that, this particular problem, and then we will solve it. So before we solve it we need to understand few things here. So this is the question, what we need to get the solution here. So before we answer to these questions, we will see some different types of vector. So what are the different types of vectors? First one, we can tell you the zero vector or null vector. Okay, means here the vector has a starting point and initial point is in the same, so we can call this zero or null vector. So starting and initial point same. Number two, we are telling about unit vector. So here the magnitude is 1, magnitude is 1 and it is denoted as say n cap or I cap or j cap or k cap. So the cap means, so this is unit vector, it has 1 magnitude. Okay, now we will see, so there are varieties of vectors. So we have negative vectors, we have like vectors, unlike vectors, coplanar vector, and so on. Different types of vectors are there. So another thing is there, main point what we will need in our next session, it is equal vector, equal vectors. Okay, so here equal vectors means two vectors will be called as equal and that will be written as A equals to B. Two vectors are equal if they have same magnitude and same direction regardless of their initial point. So this is very important, same magnitude and same direction regardless of their initial point. So I'll just explain this one because this is the main concept we will be using in the next session, right now exactly in the next session. So this is, let's say this is a vector A, and this vector, let's say it is lying with the horizontal making an angle theta, and it has a magnitude. So if I call this a vector A, then magnitude of this vector we denote as like this, or we can write simple A. So this is the magnitude, this is the magnitude part. Okay, now if I draw another vector here and same magnitude, another vector B, let's say, and magnitude of A is equal to magnitude of B, and it is also making same angle theta like this angle same, then we can call A equals to B. Okay, so these are called equal vectors. So now we will see vector addition, how we can add two vectors, addition of vectors basically. Addition of vectors. Let's say we have two vectors. So the point where we have left the question, so we have two vectors, vectors A and vector B, making an arbitrary angle with each other, and I will draw. So this is B point, this is C point, and I just draw the shortest distance from starting to the end of the second vector, and I connect them, and then I get AC. So AC is basically vector A plus vector B. Okay, so this is we are calling as vector C. So vector C equals to vector A plus vector B. So there are some properties of vector addition. So what are those properties? First one, A plus B, vector A plus vector B, we can write as vector B plus vector A. A plus B equals to B plus A. It is the same thing. Again, we can tell A plus B plus C is equal to A plus B plus C, we can do, or we can do A plus C then plus B, we can do. So this is the same way we can do. So this is one property, this is second, and third property we have A plus vector A plus 0 will be vector A, and same way we can use the fourth property, vector A plus minus vector A equals to 0. So these are the important properties of vector addition. Vector subtraction is nothing but the addition of negative vector. Vector subtraction. What is vector subtraction? it is addition of negative vector, I can put that way. Addition of negative vector. What does it mean? See, I have, first let's understand what is negative vector. Okay, I have vector A like this, so it is vector A, and if I draw the vector with the same magnitude but in opposite direction, so this is A and this is called minus A. Magnitude this and this same but direction opposite, same magnitude but opposite direction. Same magnitude is opposite direction, called negative vector. Okay, now how do I subtract two vector? So let's say again in the same example, this is vector A, this is vector B. So this is A, this is B, and I draw this one A plus B, right? I draw this one A plus B, and this is vector B, and if I draw this vector in the opposite direction, if I draw this vector in the opposite direction with same magnitude, so what I get? Minus B, right? Now if I get this vector, so minus B, then if I join the starting point of the first vector and the ending point of the second vector, then what I get? A plus minus B, because this is minus B, so basically it is coming A minus B. So this is the subtraction, vector subtraction. This one addition, this is subtraction. Okay, this is addition and this is subtraction, and this is the way we can do the vector addition, vector subtraction, and all these things. And we have to remember these are the technique. Okay, now another important part we are going to cover here, that is the component of the vector. Component of vectors or component of vector, let's say component of vector. Okay, so I have again one vector A like this, and if I draw x y axis like this, and it is making an angle theta, so this side it will be A cos theta, and this side will be A sin theta. So these are the two components of the same vector A. So this is the way we normally use the vector component. Another important point, we have to deal with vector product. Now we will see. So now let us see the components of a vector. We can draw a vector on xy plane. So as per usual convention, this is y axis and this is x axis, and let us draw the vector A making an angle theta with x axis. So this is vector A, and this point let us consider P, this is O, and we draw a perpendicular from point P on x axis, and let's give this position L, and this is also another perpendicular drawing on the y axis, and this gives this K. So now from basic trigonometry we know that cos theta equals to, and this distance OL, let's consider AX along x axis, and OK is AY along y axis. So cos theta we know AX by A as OP is A, that magnitude of the vector A. This is magnitude along x axis, this is magnitude along y axis. Okay, and sin theta equals to AY by A. So from this what we get, AX equals to A cos theta and AY equals to A sin theta. So if we just do AX square plus AY square from the above two equations, we get A square into cos square theta plus sin square theta equal to A square. So we know sin square theta plus cos square theta equals to 1. So putting this value 1, we get A square. So therefore A is coming root over AX square plus AY square, and this is the important formula, and we all know that from trigonometry we are getting this important formula. Now this formula we need to remember for our any future derivation or any component analysis or getting the resolution of the main vector into two different components. So we need to remember this one. So if we generalize this formula, and again I will draw the same thing on xy plane, and what we get, let's say this is my vector R and this is the angle theta with x axis and this is the y axis, and what we get, this vector R, and if we can write in a generalized form vector R equal to xi plus yj, where I and j are the unit vector along x and y axis respectively. So these are the unit vector. Unit vector means, as I told before, it has magnitude 1. So this is also another generalized form what we get. Okay, so now we will see the same component in